The saddest aspect of life right now is that science gathers knowledge faster than society gathers wisdom. That's Isaac Asimov. Welcome to the deep dive. And that quote feels particularly relevant today because we're plunging into artificial intelligence, AI.
Definitely. It's fascinating, complex, maybe even a bit alarming sometimes.
Exactly. We're going to unpack its history, look at what it can do right now, which is frankly staggering, and crucially what it means for all of us. And, this deep dive is especially important if you're keeping up with current affairs, maybe for competitive exams like the UPSC, or honestly, if you just want to be properly informed.
Right. We're digging into a really insightful piece from the print today.
Yes, a really thought-provoking analysis.
So our goal, really, is to pull out the key takeaways for you, give you a clear shortcut to understanding AI's roots, its power today, and the implications, especially for India.
What you'll get is a solid grasp of how AI evolved its impact right now, particularly in some surprising areas like advanced math, and what it suggests about, well, the future of creating knowledge, and maybe even our own thinking. Okay, so let's get into it. To really understand today's AI, the really flashy stuff, we actually need to go back, way back.
Yeah, back to the 1980s, to a piece of software most people have probably never heard of. It was called Graffiti.
Graffiti, okay. Tell us about that.
So Graffiti was developed by Simeon Futlovich at the University of Houston. And it was a really pioneering step into AI, specifically in computer science and mathematics.
Pioneering how? What did it actually do?
Well, back in 1986, it could generate new mathematical problems, non-trivial ones in graph theory.
Graph theory, that's like networks and connections. Right?
Exactly. Studying relationships between things, like social networks, maps, that kind of structure. So Graffiti was creating new puzzles in that area. By 92, it was even generating major conjectures, basically. Educated guesses needing proof in chemistry and graph theory.
Okay, here's where it gets really interesting for me. The New York Times actually wrote about it. And get this, some of the biggest names in graph theory, even the legendary Paul Urbis.
Oh, yeah, Urbis himself.
They were publishing papers proving conjectures that this software had come up with.
It's pretty wild, isn't it? A computer setting homework for mathematical geniuses.
Totally flips the script. So why do we call Graffiti AI? Looking back.
Well, it showed traits we associate with AI. Things like automated reasoning, problem solving. And importantly, generating novel ideas, new conjectures that seem to mimic human creativity in math.
It wasn't just crunching numbers, it was suggesting new directions.
Precisely. It had autonomy in making these conjectures, and it genuinely impacted research. Even Paul Urbis, a giant in the field, acknowledged working on its problems. That says a lot. It was an early seed, definitely.
So if it was doing this amazing stuff back then, why didn't AI just explode immediately? What took so long for us to get to, well, today is AI?
That's a great question. Graffiti was like a proof of concept almost. But the broader field needed more. We just didn't have the raw computing power back then.
Right.
Or the massive data sets that fuel modern AI. Think about the internet, all the digital information we have now that didn't exist.
Okay.
And neural networks, the algorithms, they were understood in theory, but we hadn't figured out how to scale them up effectively. So Graffiti planted seeds, absolutely. But it took decades of progress in data, hardware, algorithms, the stuff behind large language models now for things to really take off.
Makes sense. The foundations were laid, but the ecosystem wasn't ready.
Exactly. So the recent surge feels sudden, but it builds on that early work. It was almost inevitable once the other pieces fell into place.
Okay, so fast forward from Graffiti to now, and things are, well, they're moving at lightning speed. It's exciting, but like you said, maybe a bit alarming too.
Definitely both.
Because the capabilities we're seeing now are just staggering. But it's also complex. Not all AI is the same, right? Our source material mentions this specifically.
Yes, a crucial point. The author actually tried using some chatbots, supposedly specialized in math.
Right, and what happened?
They gave answers instantly, very confidently, but they were wrong for advanced undergraduate level questions.
Confidently wrong. That's a combination.
It is. And it contrasts sharply with this other event, a sort of secret meeting in Berkeley, California, just this past May.
Secret meeting. Sounds intriguing.
Well, maybe not secret, but low-key. About 30 top mathematicians got together. They came from all over, even the UK.
Okay, why?
To challenge a specific chatbot, a reasoning chatbot. They spent 2 days throwing really tough professor-level math problems at it.
Yeah.
It solved all of them, every single one.
Actually, all of them.
Yep. Ken Ono, who led the session, he's from the University of Virginia. He was basically the judge. He said, and I quote, I have colleagues who said these models are approaching mathematical genius.
Mathematical genius. Wow. Okay, so what was the difference? Why did this bot succeed where the author's specialized bots failed so spectacularly?
Ah, the crucial difference lies in the type of AI and its training. The Berkeley bot used something called a 4 Mini.
A 4 Mini.
Yeah, it's a large language model from OpenAI, but it's specifically focused and trained on reasoning. Mathematical proofs, logical steps, that sort of thing.
So it's not just pattern matching based on seeing lots of text.
Exactly. Think of it less like autocomplete for math and more like something trying to actually follow the logical steps of a proof. The other bots the author tried, they might have recognized the shape of the problem, but couldn't genuinely deduce the solution. O4 Mini is trained on the process of reasoning.
That distinction feels incredibly important. And the source gave an example to really ram this home, right, about PhDs.
Yes, at Imperial College, where the author got their PhD, a doctorate there usually takes, 4 years. Doing it under 3 is seen as exceptionally bright.
Okay, standard time frame.
Well, this O4 Minibot, faced with a difficult PhD-level problem, solved it in 10 minutes.
10 minutes.
10 minutes. And with, again, supreme confidence.
That really makes you pause. You start wondering about the whole structure of research, PhD programs, everything.
Absolutely. If AI can do that, what does it mean for human research? For how we discover new knowledge in math and science?
Yeah, it's a profound question. Which leads us to the bigger picture. What does all this mean for us? For knowledge, for how we think, and, importantly, where does India fit into this picture?
Well, Ken Ono, the mathematician from Berkeley, he raised a really significant red flag. He's worried we'll just believe these things because they sound so sure of themselves.
Right. He called it something, didn't he?
Proof by intimidation. His words were, if you say something with enough authority, people just get scared. I think a 4 Mini has mastered proof by intimidation. It says everything with so much confidence.
Proof by intimidation, that's unsettling, especially now with misinformation being such a problem anyway.
Exactly. It taps into that human tendency to just accept things when they're stated forcefully. So you have this incredible potential, but also this real risk. We should be, as the source suggests, both excited and alarmed.
Excited and alarmed. That sums it up. And this alarm part brings us squarely to a critical point from the source material, India's position in all this. For, listeners thinking about UPSC or just national strategy, this is key.
It really is. And the author's observation here is, frankly, quite troubling, based on decades of interaction.
What did they find?
They found that among graphs theorists and computer scientists they knew in India, basically no one showed interest or knowledge in using computers the way Graffiti did for that deep conjecture generation, automated discovery in math.
So not using computers as creative partners in research?
Essentially, yes.
Yeah.
And this wasn't just a one-off chat. The source points out there isn't a single graph theory course in India that teaches these kinds of computer-aided discovery methods. It's a systemic gap.
Wow. So even though India is known for, coding skills, software services, we've somehow missed the boat on this deeper AI-driven knowledge creation aspect.
That seems to be the core argument. The article puts it down to, quote, unimaginative curricula and a lack of intellectual boldness.
Unimaginative curricula and lack of intellectual boldness. Can you unpack that a bit? What does that look like in practice?
Well, the unimaginative curricula part suggests an education system perhaps too focused on rote learning, on exams, rather than fostering, say, experimental thinking or real interdisciplinary work, which is vital for AI innovation.
Okay.
We're great at applying existing tech, but maybe not as strong at generating fundamentally new approaches using computation. The lack of intellectual boldness implies perhaps a reluctance to take risks in research, to ask really out-there questions, maybe sticking to safer, more established paths instead of exploring the unknown with tools like AI.
Right. And the consequence, the author fears India might pay a heavy price for neglecting this for, 4 decades? What kind of price are we talking about?
It's potentially huge.
Yeah.
Not just missing a tech trend, but maybe missing out on future economic growth, strategic advantage. If we're not creating with AI and fundamental science, finding new materials, designing drugs, building advanced reasoning systems, we risk becoming just consumers of AI developed elsewhere.
Which has implications for everything from the economy to, national security.
Absolutely. Dependence on foreign AI models raises issues about data, ethics, control. It's about potentially falling behind in innovation across many critical sectors. It's a really serious concern about our future trajectory.
So for you listening, whether you're tracking this for UPSC, trying to understand India's place in the world, or just curious about the future, this really highlights how urgent it is to engage with AI critically. Not just the hype, but the deep strategic questions. It leaves us with a pretty big question to chew on, doesn't it? Considering AI's power and that very real risk of proof by intimidation, how do we cultivate that intellectual boldness? How do we learn to use this incredible tool for real progress without just being, steamrolled by its confidence? Something to think about.
Definitely. We hope this discussion has given you some valuable context, a shortcut to understanding a really complex and fast-moving field.
Yeah, we hope so too. If you found this useful, or if it sparked more questions for you about AI or India's role, please do give us a like, subscribe for more deep dives like this one, and definitely drop your thoughts or questions in the comments. We genuinely want to hear from you.